Hello, I'm Eric Nersessian. I'm presenting some research on virtual collaboration training for freshman undergraduate STEM students. Other authors on the paper are Jessica Ross Nersessian, Adam Przinski, and Dr. Michael Lee. We are all from the Department of Informatics at the New Jersey Institute of Technology in Newark, New Jersey. So, a learning community is a group of people with common academic goals. They're beneficial for overall student experience, as usually there's students that are friends in classes that can continue training and learning with each other outside regular class time. So that the New Jersey Institute of Technology, or NJIT, on average every year has 700 freshmen that come in to attend the learning community version of our freshman year seminar, and an additional 215 that need to attend a supplemental, a reduced freshman year seminar that doesn't have this learning community attribute connected to it. That means about a quarter of our incoming students need some type of alternative tool to learn about learning communities, to uh, acclimate around their irregular schedule or whatever the issues are that they can't attend the normal learning community session. And so virtualizing learning communities can have potential to expand and create new learning structures where they weren't able to exist before. In this case, we're going to pilot a study on learning community training with both physical and virtuality teaching methods. So both our learning community and non-learning community freshman year seminar has no explicit socialization or collaboration training. The version of learning community training is some additional engineering classes that are supposed to just solidify the students with their same degrees and disciplines. But the instructors are usually engineering focused and don't have the skill set or the aptitude to offer direct collaboration training, nor is there actually curriculum for that explicit training. Our freshman year seminar director also stated issues that with dealing with instructors and curriculum and space and scheduling issues, since it is this seminar zero credit class that a lot of instructors do for their service commitment. Not all students can access the physical training. It can be expensive. There's a large commuter and irregular or adult student groups to NJIT. And so virtualizing this learning community training could help reduce this cost, space, instructor limitations, and we could increase benefits to a wider student body. So we decided to investigate if any type of direct, explicit collaboration training impacts academic performance of these incoming undergraduate students, if virtualizing collaboration training is a viable alternative to the physical format, and if users of either have any comparable perceptions of the experience, if the method impacts the user perception of collaboration. So learning communities are well researched in maximizing informal learning opportunities outside the classroom. They also provide significant positive impact to participants' academic performance. Developing these skill sets, dealing with collaboration, communication, networking, is critical for students to form these learning communities independently. And it's especially true for STEM students who might need some additional training in their social skills. So, virtual learning community environments actually have been shown to produce similar results to the physical learning environments. Virtualizing learning communities can give the potential to expand existing and create new learning structures. Cost effectiveness of virtualization can further reduce learning community obstacles in adoption by educational administration. And also, educators are already taxed and exhausted, and they need new tools to help them improve these learning experiences. So, in this experiment, we are looking at how does a virtual learning environment impact collaboration training? Is a virtual learning environment as effective as in-person instruction? How does this virtualization of the learning environment impact the perceptions of the users? In here, you can see on the left the students in the virtual reality group, in the physical surroundings. In the middle, this is the group what they're seeing inside virtual reality, and on the right-hand side, the physical format of the learning community training. So, in this experiment, we wish to examine if virtual reality learning community training has the same benefits as in-person learning community training. We recruited 90 incoming undergraduate STEM freshman students at NJIT from over 60 freshman year seminar sections. And we randomized the participants into 3 exclusive groups: a control group, a physical treatment group, and a virtual treatment group. So the control group had their freshman year seminar as is, which included a learning community in the freshman year format, which was just like an additional engineering class with students of similar degrees or disciplines, but no direct or explicit learning community training. And then the physical and the virtual treatment had the exact same freshman year seminar, but they had an additional learning community training. They had that explicit socialization or collaboration training in their respective treatment. And you can see the assessments on the right-hand side. Basically, all the assessments were the same, pre and post, except the treatments had an additional interview process at the end. So for the implementation, we had groups of 4 in the physical and the virtual reality treatments. We had 8 weeks of collaboration training. So this is in the fall semester, which lasts 15 weeks, so about half the semester. And for that half a semester of training, they had 1 hour per week on Wednesdays, which are our common hours. So we did groups of 4 because the virtual reality group was using a piece of software called Facebook Spaces. It's a networked virtuality application, as you can see in the center, allowing up to 4 participants into a shared virtual space. They stand around a table and they use tools such as they can talk to each other through a microphone. They can use a pen to draw in 3D space. They can use playing cards, rolling dice, and can bring in 3D models for examination. So that piece of software was confined to 4 people. So that set our limit on the physical group so that they had the exact same variables of group size. And we also found that groups of 4 were a nice size. It was small, it wasn't intimidating to the number of participants, and less than 4 didn't seem like a group that was able to, it seemed less people, more like an individual situation. The freshman year seminar runs for half the semester, so we timed the training with that, although we did the assessments, the post-assessments, all the way at the end of the semester to see the final grades. And we did 1 hour of training a week. The curriculum was co-designed with the freshman year director. Again, on the left-hand side is the participants in virtual reality. In physical space, in the middle is what they're seeing in their virtual space. On the right-hand side is the physical group. So the curriculum, we have 8 weeks. Physical treatment on the left, virtual treatment on the right. And you can see that the virtual reality treatment was tiered 1 week behind physical because they needed a week of being introduced to the technology. So they need to know how to use the headset, they need to know how to log in, they need to know how to use the hand controllers, and just get used to like socializing a little bit in the space, while the physical group in week 1 did the first activity, Lost at Sea. On the right-hand side, you can see that is the Lost at Sea activity done in virtual reality. So it's a group discussion. You have to try and sort the list of items to maximize your chance of survival as a group that's lost out at sea. Most of these activities were discussion-based, or philosophical arguments, or logical puzzles, or data visualizations that the group had to discuss and come to a conclusion within that 1 hour period. So here is our social and academic metrics. On the left-hand side is the social metric. They were used weekly throughout the 15 weeks of the fall semester. And it's based off social network analysis, which is a very established social measurement for virtual social networks such as Facebook and LinkedIn. And we asked that we defined what is a help. Did you give help or did you take help for this week? So help is, did you give or take 5 minutes of direct instruction or tutoring from a colleague in your class outside of class time? It could have been in a cafeteria, over the phone, in the gymnasium. It's just, did you talk to one of your classmates and get help, or did you give help for 5 minutes outside class time? And please list these people. And so we looked both directions, giving and taking help, and who are these people that you're helping? Are they the same people or different people that you're helping every week? And on the right hand side is our academic metric. All of these freshman students have to take Common Core science and math classes. So we had a series of classes that are very standardized at the STEM university. And the Common Core classes need to have 4 Common Core exams throughout the semester. So we had many data points to gather from. So besides these 4 Common Cores, which happened at the same set of time, we looked at their final exam grades. And what they thought they got for the class. So they were ranked on A to F, and they listed the class and the grade that they think they will get. These are self-reported grades that we converted over to a number scale. So here's our interview protocol. We did interview the physical and the virtual reality treatment groups. And we did 1 hour semi-structured interviews. We had 26 come from the virtuality group, 19 from the physical, for a total of 45 interviews. We structured 23 questions that were focused about how they thought about the collaboration, which activities did you like, which are you more likely to ask for help in small or large groups, are you more likely to socialize in small or large groups with your fellow classmates now? So we used a 3-stage coding process defined by Campbell for intercoder reliability. We had 2 researchers. The lead one went through the interview transcriptions and defined codes and gave 10% of the interviews to a second researcher to evaluate. And they reached past the minimum of intercoder reliability and got to 88%. We ended up generating 52 codes, and that were grouped into 10 major themes. And we counted up the frequency of the codes and placed them into categorical or a histogram. Here we have the results for academic difference between the treatments and the control. So these were self-reported grades that we counted up these Common Core exams and their final class grades. We went on a scale from 1 for F up to 5 for A. This was ordinal count data. The data is not normally distributed. These are unpaired groups, and so we used Mann-Whitley test. And we found that both treatments have a higher grade average compared to the control, meaning the physical treatment and the virtuality treatment both had statistically higher class grades than the control group. So if we look at the graph on the right, we see that the physical group compared to the control group had statistically higher grades of a p-value of 0.016, and the virtuality group compared to the control group had statistically higher grades at p of 0.041. The 2 treatments did not have statistical significance, but both treatments were statistically better than the control group. Here we have our social assessment, and we do see some social assessment difference from the VR treatment compared to the control group. So we looked at the total count of social interactions for all 3 groups and the directional sum, so meaning giving help and taking help, and then the total, the adding both together. We found this was discrete data. The data is not normally distributed. These are unmatched groups, and we used chi-squared test. We found that the VR treatment gave more help compared to the control. So here we have the VR On the right-hand side control, on the left on the graph, we have a p-value of 0.0175 compared to the two. So the VR treatment gave more help statistically compared to control. Here we have our interview results, our interview codifications of the two treatments, the physical and virtuality treatments. We totaled the frequencies, we ordered the codes into themes, and we created histograms for this categorical data. And we found that the virtualizing the collaboration may impact perceptions on leadership roles and group functions. So if we look at the graph on the left-hand side, we see perception of roles in the collaboration. So this is the theme. Underneath the theme, we see three codes that have a statistical difference that we wish to report on. So the codes were natural, follower, and ability. So we see the virtuality group in blue and the physical group in orange. So the virtuality group reported higher on the natural and the ability codes for their perceptions of roles and collaboration, while the physical group reported higher on their perception of roles of being a follower. So the virtuality group saw themselves, their roles and their collaboration within their team, that their roles were natural, that it's based on their abilities, more of a leadership situation, where the physical group saw themselves more as followers. On the right-hand side is motivations behind the collaboration. So here we have the physical group in orange is talking more, has more codes dealing with sharing ideas, while the virtuality group has more codes that they're talking about as far as shared workloads are helping. So as far as motivations behind collaboration, what the treatment participants thought about, the physical treatment thought that the motivations, the point of collaboration is to share ideas, while the virtuality group thought more that it's about sharing a workload, it's about helping each other. We saw some interesting diversity of group mentalities, how they liked to interact with each other. We saw that there was kind of a scale of emotional maturity for the groups and how they would interact or how successfully they would interact with each other, ranging from the least mature of not ripe yet. They still felt like they were high schoolers. They were too timid to talk in front of each other. Like they like to goof around and play more. These are the least amount of groups. But they're not ready for interaction. They needed unstructured playtime to pull themselves out of their shell. And for conversation and goal-oriented activities, they just fell apart. Then next, we saw there were doers. We said that they were more emotionally mature. Their interactions peaked around games and puzzles. But they didn't like to have conversation-based scenarios. It was too confrontational for them. And then the most mature groups we saw were these talkers. High interaction around conversation, philosophical situations. These groups talked the most. They didn't need to be warmed up, and they came in and they did what they need to do, and they kind of left as a group. So, in conclusion, we saw that STEM undergraduate students do improve their academic performance, regardless of live or virtual learning community training. Any type of direct, explicit learning community, collaboration, socialization training really does help the academic performance of incoming freshman STEM students. We saw that the virtual treatment or the virtual reality treatment gave participants gained more academic help to peers in social settings compared to their control treatment. And we saw that virtualizing training may impact perceptions on leadership roles and group functions. And this experiment suggests, or the results suggest, that virtualizing learning environments are successful as alternative tools to live instruction and collaboration training. Thank you.